Let's take a look at finding the domain with rational functions. And we're going to have a couple different situations here, but this first problem has basically two polynomials, right? You have negative 5x squared plus 4x in the numerator and 2x squared plus x minus 6 in the denominator. Now, the numerator, in this case, we don't even really have to worry about it, right? Because polynomials are defined for all real numbers, and there's no values that are going to, be outside of the domain of that function in the numerator. However, in the denominator, we can't have a 0, right? So we're going to have to factor the denominator and take a look at where our zeros are at in the denominator, and that's where we're going to have vertical asymptotes that create discontinuity. Hence, we have to notate them in the final answer for the domain of the function. Okay, so when I look at this, right, there's only one way to multiply to 2x squared when we're talking about factoring, and it's 2x times x, right? And then I just kind of guess and check, right? Like, let's do one wrong on purpose, and then we'll do a right one. So I guess, I need something that multiplies to minus 6 here, right? So positive 6, negative 1. Well, if I did that, I would have negative 2x plus 6x, which would give me 4x. And I need a positive 1 in the middle. Okay, so obviously that's not going to work, right? So then I just kind of continue that process. Let's check another number. Well, I'll give you the right one here. So let's use, if we talk about, we need a positive 1. If we have 2 times 2, it would give you 4x minus 3x. Well, that's going to work out, right? So let's go ahead and rewrite this now. So what we really have is 2x minus 3. X plus 2 cannot be equal to 0. So x cannot be equal to 3 over 2. That's me setting this one equal to 0. And x cannot be equal to negative 2. Okay, so both of those spots are going to be where we have our vertical asymptotes in the function. So we'll go ahead and record our answers here on the number line. And I leave open dots because it's not going to include those numbers. But everything before and after those numbers is good. So this is how we would write our final answer for the domain. Our domain now would be negative infinity to negative 2. We're going to put a break there with the union. And then we have 3 over 2 where we need another break. And then we will go to infinity. So that would be our final answer for domain in this first problem. Okay, let's move on to another problem. So we're going to look at square root of x squared minus 11 over 3x squared plus x minus 10. Okay, so now we have two things to worry about, right? In the numerator, we got a square root, and square roots have to be greater than or equal to 0, okay? So now I'm going to say, well, then x squared has to be greater than or equal to 11, and hence x, you got two situations, has to be greater than or equal to square root 11, or x has to be less than or equal to negative square root of 11, okay? So we got two situations here, and then we got to factor the denominator, okay? So this one I'll kind of write this out how I would do it the long way, and that would be 3 times negative 10 gives me negative 30, and I need factors that add to positive 1 of negative 30, so that would be 6 and negative 5, okay? So now I'm going to go ahead and I'm going to rewrite this as 3x squared plus 6x, and then I'm going to put minus 5x. I'm going to put this in a different color here because we're going to do this as a factoring by grouping. Cannot be equal to 0, okay? So then we'll say 3x times x plus 2. We're factoring out 3x from these two terms. And then we're going to factor out negative 5 from these last two. Okay, so that cannot be equal to 0. Okay, so now we got a couple things happening here. 3x minus 5 and x plus 2 cannot be equal to 0. So what does that really mean? That means x cannot be equal to 5 over 3, and x can also not be equal to negative 2. Okay, So let's set up our number line so we can write our final answer here. And you're going to see something kind of interesting happening. Well, we got negative square root of 11. And if you want to estimate that, well, think about square root of 9 is 3. Square root of 16 is 4. So maybe this is like 3 point, I don't know, we'll say 3.2. Could be 3.3, but as long as you're kind of close, it's enough for you to, kind of understand the value. So we got this negative square root of 11, right? We're going to include that. And then we have square root of 11. And notice what happens here. Actually, these two values fall in between negative square root of 11 and square root of 11. Okay, so we have negative 2 here. That's going to be an open hole. And then we have 5 over 3 here. And what's actually happening here is that x has to be less than or equal to negative square root of 11. And it has to be greater than or equal to square root of 11. So everything in the middle doesn't matter. It's not part of the domain. So we're not even going to even note negative 2 and 5 over 3 in our final answer because it's already not part of the domain, the values before and after it. But we do have to notate the square root of 11. So here's going to be our final answer here. We have negative infinity to negative square root of 11. We're going to have a bracket here. And that, again, is because it's in the numerator. And we can have a function equal to 0 for a square root, but it can't be less than 0. Okay, and then we're going to have square root of 11 going to infinity. Okay, so that would be our final answer here. Okay, let's look at one more of these. And this one is going to be a slightly different situation. Notice this one is different than my last question here because this is square root of 25 minus x squared. Okay, and here we had x squared minus 11. So notice the x squared has to be either a really small negative number, which when squared turns positive into a large number, right? Or a larger positive number that gets squared so that you have a positive square root. Well, in this case, it can only be so large. It's going to be the opposite. It's going to be an enclosed region here. Okay, so let's go and set this one up. So 25 minus x squared has to be greater than or equal to 0. So that means negative x squared has to be greater than or equal to negative 25. Now, if I'm going to solve this and I divide out the negative, that's going to flip this inequality, right? So what we're really saying is that x has to be less than or equal to 5, or x is greater than or equal to negative 5. Okay, so already we kind of have an idea here. We got negative 5, we're going to color that in. And we got 5, we're going to color that in. So it's actually going to be this area here in the middle. Right? But we haven't dealt with the denominator yet because we need to figure out where there's zeros in the denominator. So I'm going to go ahead and look at that. So this cannot be equal to 0. Well, when you're solving an a absolute value like this, well, we're going to move the 3 over first. And now when you look at this, right, really inside the absolute value could be negative 3 or 3. So we're going to split it into two situations. So we have x minus 2 cannot equal 3, and x minus 2 would not be equal to negative 3. Okay, so that would be where it's inside of here, it's negative, but it's absolute value, so it would turn positive. Okay, so our two solutions then are x cannot be equal to 5, and x cannot be equal to negative 1. All right, so our negative 1, let's put it a little more over this way. Our negative 1 would be right here, and we're going to have an open circle because it's not going to include that. Now we got a problem here. We were going to include 5, right? But if it gives us a 0 in the denominator, we cannot include it. So that's going to change this one to be an open circle here. Now remember, I talked about it's just going to be this enclosed region. So what's going to happen is everything greater than negative 5, or greater than or equal to, it will include negative 5, and then everything up until 5. Normally we would include it, but because of this, we have to not include it because we can't have a 0 in the denominator. So here's our final answer then. We're going to have a bracket for negative 5. We're going to have a break at negative 1 because that's going to be a vertical asymptote. And then we're going to also go all the way to positive 5, but we're going to put a parentheses here because it does not include it. Okay, so remember, Let's make this parentheses look a little better, but we're going to have parentheses here because it does not include it. And all of this is outside of the domain because it doesn't work for that square root. So that would be our final answer here.